do that. So for number, thank you. Okay, so for number 2, you were trying to find the X and Y intercepts. So let's do that first. So to find the x-intercept, remember that we plug in 0 for y. So we're going to have 0 equals x minus 3. Just add 3 to the other side, so then our x-intercept is positive 3. Right, then to find the y-intercept, we're going to plug in 0 for x. So we have y equals 0 minus 3, which means that our y-intercept is negative 3. So then on the graph, right, so at x equals 3, we're going to put a dot. And then at y equals negative 3, we're going to put a dot. And then we're going to connect those 2 dots with a line. So that's what your graph should look like. Okay, so then let's go ahead and move on to number 4. Your hand. Yeah. Sure. Okay, yeah, we can do number 1 at the end. That's fine. Yep. Oh, sorry, Abby, I didn't see. Okay. All right, so then moving on to number 4. So we have y equals negative 2x plus 10. So again, to find the x-intercept, we plug in 0 for y. So we have 0 equals negative 2x plus 10. All right, we want to subtract 10. So negative 10 equals negative 2x. Divide by the negative 2 to get x equals 5. For the y-intercept, we're going to plug in 0 for x. So we have y equals negative 2 times 0 plus 10. The negative 2 times 0 cancels out, so then we get y equals 10. So then for our graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's really small. No, it's too big. Oh, 10. All right, either way. So then x equals 5, we're going to have a dot, and y equals 10. And then we will draw a better line than I just drew and connect them. All right, so how do we do on 2 and 4? Good? All right, was it the ones with the slope that we struggled a little bit more with? Okay. Huh? Okay. All right, so then number 6. So we're given the point 1, 1 to start with and a slope of negative 7. And I'm going to go ahead and put that over 1. So I'm going to actually... I probably can't do that well. Okay, so I'm going to go ahead and draw a graph. All right, so the first thing I'm going to do is I'm going to plot my point 1, 1. So that means I'm going to go to the right 1, up 1, and put a dot. Right, so since we have a slope of negative 7, right, so we put it over 1. So that means we're going to go down 7 and to the right 1 from that yellow point that I just drew. So we're going to go 1, 2, 3, 4, 5, 6, 7, and then over 1. So you don't really need these little dots. I just kind of use them to count with. Right, and then honestly for this one, that's pretty good. So it's going to be a very steep kind of line. Oh, I can already tell that that's not. Right, so it's like almost vertical, but not quite. From that yellow point, you could have also gone up and to the left. So you could have gone up 7. 1, 2, 3, 4, 5, 6, 7, and then over 1. So if I like extended my line, you can see that that point would still fall on that line. So that works. You could have done either way. All right. So does that help with number 6? Okay. Then for number 8. Alright, so we're going to plot the point 5, 4, and then it has a slope of 2 over 1. So over 5 and up 4. So that's our starting point. And then from there, since it's positive 2, we're going to go up 2 and then right 1. 1, 2, and then 1. And then you can just keep doing that if you want to get some more points to like make a straighter line. So you just keep going up 2 and over 1, put a dot, up 2, over 1, up 2, over 1. So that slope is just telling you how to keep moving to like keep plotting points that are going to fall on your line. And then just remember for a positive slope, you can also go down and left. So like from my red point, I could go 1, 2, and over 1. And see how those all still fall on my line? All right, so that means you can go either way. All right, what questions do we have so far? I know. Chance, did that answer your questions for 6 and 8? Okay. All right, and then number 10. So we have the equation negative x plus 3y is equal to negative 9. So we need to first put it in slope-intercept form, right? So we want to get y by itself, so we're going to add x to both sides. So then we have 3y equals x minus 9. Then we're going to divide everything by 3. So then we get y equals 1/3 x minus 3. Right, so x over 3, you can just like pull that out as 1/3, which is helpful because that's your slope. So you're going to want that as like its own fraction. So then remember that this minus 3 is your y-intercept. And then this 1/3 is your slope. So then on your graph, right, so we're going to go 1, 2, 3. So we're going to put our negative 3 there. And then from that, we're going to go up 1 and over 3, right? Because the slope is 1/3. So the top number is up. Bottom number is right. So we're going to go up 1 and then to the right, 1, 2, 3. Put a dot. And I'm going to do it again just to give me a better line to draw. 1, 1, 2, 3. So especially when your points are like close together like that, I think it's helpful to give yourself at least 3 points. That way you can get a nice, neater line, hopefully. Okay, questions on number 10? Huh? Yeah. All right, and then finally for number 12, you have negative 6x plus 2y is equal to negative 10. So to put it in slope-intercept form, we want to solve it for y. So we're going to add our 6x over to the other side. So then we get 2y equals 6x plus 10. And then divide by 2. So then y is 3x plus 5. Wow, yes, thank you. That's a negative 10. Minus 5. Thank you. So then again, on our graph, So we're going to plot the -5, and then from there we've got our slope of 3/1, so we're going to go up 1, 2, 3, and then to the right 1. And 1, 2, 3, right 1. And get a line that looks like that. All right. Questions on number 12. All right, so in section 4.2, if you're following along in your book, we're on page 164 at this point. And we're going to talk about point slope form. So basically what point slope form allows us to do, it lets us write the equation of a line when we're only given, so like in problems like 6 and 8 that we just did, when we're given a point and a slope, it's a formula that allows us to write an equation of that line in slope-intercept form instead of just graph it. So point slope form looks like this. So it's y minus y1 equals m times x minus x1. Right, and so we will be given, right, so you're going to be given m and a point, which is your x1 and y1. Right, so just like in our slope-intercept equations, like this y and this x, we're not going to plug anything in for. We want those left there. Like we need an x and y in our final equation. So let's go ahead and apply that and do an example. So let's say that we're given a slope of 2/3 and the point 3, 5. Try to give myself a little bit more room here. So we're going to basically take those numbers, plug them into our point slope form. So remember we have x1 and y1. Right, so we have y minus y1, which is 5, is equal to m, which we know is 2/3, times x minus x1, which is 3. So let me highlight and kind of show you what I did. Right, so my slope is 2/3. I plugged it in here. Right, x1 went here. And y1 went here. Right, so I just plugged those numbers into my formula. And then now I'm just going to distribute here, move my 5 over, and then we're done. So we just want to solve it for y now. So we're going to multiply the 2/3 in. There we go. So this side is staying the same for now. So then 2/3 times x is just 2/3 x. And then 2/3 times 3 is just 2. Then we are just going to add our 5 over to the other side. And we get y equals 2/3 x plus 3. So now we have an equation for that line. So if you are given any point on a line and the slope of the line, you can write an equation for that line. That's all we're doing. It's more plugging numbers into a formula. All right. Is that fairly straightforward? Do you guys have questions at this particular moment with that part? Okay. Then the other thing we can do, still with point slope form, is so I'm going to go ahead and write that up here so it's handy. Sometimes we can be given 2 points. So from what we did in 4.1, we know how to find the slope between these 2 points, right? Yes? Okay. So remember that formula is y2 minus y1 over x2 minus x1. So we can still use point slope form here, but we just have to take the steps of actually finding the slope ourselves first. So we have x1, y1, x2, y2. So then to find our slope, we have y2 minus y1 over x2 minus x1. So that means we get negative 1 over negative 6, or 1/6. So that's our slope. So just like in the last example we did, now we have a slope of 1/6, and we can pick either one of our points. We can use the first one or the second one, does not matter. All right, we're just going to plug in and solve. So you could use this and use x1, y1, or you could do x2, y2 and just plug those in the same spot there. Doesn't matter. You're going to get the same thing at the end anyway. So I'm just going to use the first one. So I have y minus y1, which is 3. Right, I'm using this point. Equals m, which is 1/6, times x minus x1. So then we get y minus 3 equals 1/6 x minus 4 over 6. Then we're going to add 3. All right, so you guys have calculators, also get common denominators, but make it easy on yourself. Negative 4 over 6. So that's going to be 7/3 when it's all done. So again, at this point especially, don't make it harder on yourself by getting hung up on the fractions when you've got something in front of you that will help you out there.